So my name is Aapo. I do a lot of things with IoT, but especially for my work, security research, consulting, and mainly look at IoT and other kinds of devices. Work a lot on cryptography and network protocols. Outside of that, bug bounty. So if you run a hardware bug bounty program, you know where to find me. And I'm also a coach for a Finnish CTF team. But yeah, so here is some IoT and my trusty EPC, and I want to kind of see how it works. I might want to hack it, or I might want to check out something about it. This particular device connects to the internet with an Ethernet port or Wi-Fi. So that should be quite straightforward. If we want to know where it's connecting to, and that's a big part of IoT, we can simply plug in an Ethernet cable to the device and the other end to our laptop, and then on our laptop in the Ethernet interface, we will see any traffic it's trying to send. We can do the same with Wi-Fi. So if we have our access point, the device connected to it, and then again we will see the traffic on the Ethernet interface. But there are some kind of devices, and especially industrial IoT, that have very specialized job, and they have been made to be very cheap. So they have only one way to connect to the internet, and nowadays a big part of it is some kind of something else than Ethernet or Wi-Fi. So today we will be talking about these kind of devices. So some kind of 4G connection on this one, and how that works. There's a modem. You plug in a SIM card and it connects to 4G and it's connected to the internet. But the problem is, how do we actually see the data? So this is kind of the topic of today. There are also different kind of devices. They might have multiple ways of connecting to the internet. So here we have a phone currently connected to my Wi-Fi access point, and I can see everything it's sending to the internet. Or can I? So if you might not be able to see it, but there's a little 5G icon there, so it's actually connected to 5G as well. So the question is there traffic over 5G as well? So it might be something built in, there might be something malicious. So let's talk about that. So why would you want to look into mobile network traffic? If you're just a tinkerer, if you're at DEF CON here or watching this video, then you might be curious. You might care about your privacy. You might think, where do my devices talk to? Is there some kind of unencrypted private information flying through the air? And if you are traveling in some countries, you might want to kind of know what exactly your devices are sending. From offensive security point of view, we might think that can we tamper with the traffic and find vulnerabilities? If you do penetration testing and you have these kind of devices, you need to hack them, you need to kind of do some kind of security audit or something like that. You might want to look at the traffic. Can you actually say we've kind of penetration tested this if you haven't looked at the mobile traffic? From defensive point of view, you might want to detect malicious traffic or just filter some unwanted things. You can do this in most cases on the device. So if you have a phone, you can install something and it will kind of filter things or endpoint detection or whatever. But if you have some advanced malware on your phone, it might not respect the on-device protections. So if it's running on very low inside the operating system, it can easily just not allow the endpoint protection to run. So we might not want to do the testing on the device, we want to do it outside. So what are these mobile networks? Sometimes called like cellular networks, and these come in different flavors. There is 2 to 3 to 4, 5G, etc. Some older ones, but I think these are the currently used. And in 4G and in 5G, there are these slightly different, like NB-IoT is a special version of LTE. But the main thing is that you have different frequency bands and special radios that can talk with these protocols. Usually, the mobile networks are operated by internet service providers, so ISPs, and they have massive amounts of base stations all over the world. So if you have civilization, you most likely have a mobile network there. And how you use these mobile networks is you just buy a subscription from an ISP. They will give you a SIM card or send it to you, and then you plug the SIM card into your device. The SIM card authenticates you to the network, and then you connect. You can kind of send text messages or phone calls, but nobody really does that anymore. So it's mainly used to route IP traffic from your device to the internet or wherever you want to go. Usually this mobile network stuff, this is very specialized, and it comes in this separate hardware module called a modem, and that's a separate device on your device. These modems are very complex, usually run their own operating systems, and are basically a small computer that you just connect to your board, and then it handles a lot of things. Here you can see a picture of this. So on the left, we have a mobile device. It has a CPU and the modem, and the CPU runs some kind of operating system, Linux or Windows or whatever, and then talks with the modem and offloads the actual mobile network thing to it, and then you just give it data, and the data somehow finds its way into the internet. On 4G, we have these cell towers. So these are the base stations that are all over the world, and your device usually connects to the nearest one or the one with the least amount of traffic. So they handle it themselves. The cell tower is connected to the ISP infrastructure. So there's different kind of things. We're not going to go that in depth because this talk not only covers 4G, but all kinds of mobile networks. But usually they have similar way of operating. So first the radio connects to a serving gateway and some kind of authentication mechanism. So the SIM card from the modem talks with the auth, and then your mobile device is then, the traffic is routed with these packet gateways to the internet. So how do we intercept this mobile network traffic? So if we want to analyze it, we need to see it. To see it, we need to somehow intercept it at some point. So of course, the easiest way to intercept traffic is on the device. So just log in, run TCP dump, and you will see the network connections. So if you have a Linux-based device, the CPU is sending the data to the modem, but you can look at the traffic already on the device. So no need to any kind of fancy things. So if you can do this, it's very powerful. And especially if you want to know if your device is accepting connections, you might want to take a look at that from the device. So no need to scan all UDP ports if you just like type in a command that shows you all listening UDP ports. This, however, requires root access to the device. So if you want to hack something, you might not have this Or if you have some kind of secure device, like an iPhone, you might not be able to have enough permissions to do this. And also I said that the modem has its own operating system, might have some over-the-air updates. Some of the functionality can be offloaded to it. So for example, FTP, you can just say to the modem that, hey, download these files from this FTP server and hand them to me. And that might not be secure. And if you're just looking at the traffic on the device, you will not see that. And if you're doing penetration testing and you have been relying on this, I have bad news for you. You haven't kind of done your work really well. And we have found a lot of vulnerabilities in the modems. So if we actually want to intercept the traffic, there is the CPU, there's a modem. So how this works is they have some kind of serial interface, usually not encrypted because you don't really need to. And just kind of look at the board and find the traces and sniff them. This work with these AT commands, sometimes a little bit different, but basically the CPU says to the modem that, hey, please make a connection to Google and then send this data through that connection and you will get the traffic. So you can just kind of sniff the traffic and decode it or even replace the modem with your own software-based simulator. So this is something that we've already done. In some cases, it's quite simple. If you have kind of clear traces and you just solder your serial port adapter to it and pull the modem to reset, you can do this. But of course, it requires hardware reverse engineering and some tiny soldering. And again, there's very complex setup sometimes, so it might not be as easy as is shown here. And we cannot see the modem's own traffic here as well. I usually have written my own because it's quite simple to do, but I found this GitHub project that seems to have made similar thing. So if you want to play around with this, you can look at that and try it out. The next thing I tried to run my own base station because I want to see the modem traffic. I figured out just like I have my Wi-Fi access point, I'll do a 4G access point. You can buy this, you can build your own, and the software-defined radios can do pretty much anything nowadays. Just a couple of $100 and open source software and you can do this. A basic setup, like $1,000, not that much if you're into kind of professional penetration testing, but it requires a week worth of work to get running. And if you want to buy the commercial thing, then it's really expensive. The problem with these, the radio bands are heavily licensed. They are used quite a lot. And that means that kind of all available bands have been bought by someone. So it's illegal to run without a Faraday cage. So you need to have a kind of pouch that you put your radio in and your device in. And you have to kind of be careful not to leak the thing because someone will find you and come find you. Some of the frequency bands can be licensed. Some countries have unlicensed bands, but then you're limited into that one band or that one physical location where you are running this. So if you're into this, there's the Libre Cellular. They have good instructions how to do this, but I have something better for you. So let's go back to the 4G mobile network. We have our mobile device, it talks to the cell tower, and then there's the authentication and some other stuff. But what exactly is that other stuff? Like I said, the devices authenticate with SIM cards, and then there's some kind of packet filtering going on. There is this thing called lawful interception that kind of means that your traffic can be inspected by the authorities. And I think if it can be inspected, then it most likely is. But yeah, other things that it does is policy enforcement. So basically it means if you buy a slow speed subscription, it will make sure that you won't get good speeds. They calculate the billing, so if you have kind of per megabyte subscription, then they calculate the megabytes. Then they route the packets. So there might be some kind of ISP internal things like DNS servers. So some of the things might not go to the internet at all. So they might go to kind of internal DNS service or something else. But also the packets can be routed internally in different ways. So we have these things called APNs, which basically mean that how to route your packets inside the ISP. So this is something that if you're old, you know what these are because you've kind of gotten a new SIM card, you put it in and it doesn't work, and then you need to go to these and then you need to type something. But nowadays you might not even know that these exist. So, and if you need to type something, you just type in internet and then you get to the internet. These are actually used, so you might have some kind of restricted internet or something. So some ISPs offer some kind of child-safe things, so they do more things, or some kind of. At some point, you can kind of get more speed if you from some certain ISP. So if you don't use the internet but you use something else, then it's faster because there's less people there, or something like that. But usually, just you use what comes with the subscription. So these a big change nowadays that these are pushed usually through the network to your device. So when you connect and you don't have an APN, the modem asks the network that, hey, like, do you have something for me? And then it's automatically set up. You can change these, configure them manually on the device, but it might not be respected by the ISP. So it basically just tells the ISP, hey, this is what I want, but it can, of course, offer you whatever it wants. So there is this thing called private APN. So something that you can kind of buy as a service. So if you run big fleets of IoT devices, you might want to buy this from an ISP. So they will set you up with a internal network where your devices are connected to, and they might not go to the internet at all, or there might be some kind of, you can run your own server there or something like that. It's a private network, and they can be configured however. So routing, filtering, everything can be configured, and direct connection between the devices are kind of, at least you can configure them to be allowed. So this is a big difference to normal APNs that you cannot really do device-to-device connections, but you just have to go through the internet. These also, by default, usually they don't filter the traffic. So it's sometimes the ISPs don't really like some kind of traffic, or if you do like port scanning over mobile network, they might shut you down and you don't really know if it works or not. But so you can also set the private APN to connect you to the internet, so you have access to all these services, and then you can get also access to the internet, maybe even with a static IP that then you can configure your servers to only accept that. So then it's used quite heavily in IoT, so that's where I found out that these exist, and a lot of the customers are using these. So I kind of figured that this sounds something that kind of, if we want to do these inspect the packets and they use these same things for the lawful interception things, then it might help me kind of look at my traffic. So I had this question, could I get a private APN? Sounds expensive. And I went on a journey to send a bunch of emails to different ISPs. And I found out that there's a huge variance in price and usability. So the first place I went, they had this contact us for pricing. And they were like, yeah, we can do this, no problem. So you just pay us $3K to get started, and then $500 monthly. So I was like, yeah, this sounds a bit too much for a proof of concept. And I might as well just run my own base station in a couple of offices. The next place, they were also contact us for pricing, but I was pleasantly surprised. So they also said that, hey, just go to our self-service portal and activate it and you're good to go. And they had a $100 USD setup fee and $150 a month. So this is completely doable. There's another place, so they have this $10 setup fee and 75 cents per hour. So different pricing models. So if we look at in the similar schemes here, so the first one, if you kind of, no matter how much you use it, it's $250. But then for a year, it's just $2K. So you can rent it out easily, and other one, so $30 a day, $100 a week, and $6.5K for a year. So if you want to kind of do it for longer times, you might want to have this local ISP, and then if you just want it for a day, then you have options for that. There is a lot of difference in coverage. So some of them are really global. They offer services in all the countries. Some are US specific, some are EU specific, and even some that are just inside your country. There's also differences in the available data plans. So you still have to pay for your subscription even though you have the private APN, because it's kind of the different thing. Some of the IoT oriented ISPs, they offer really good pricing that you only pay like $2 a year if you send 100 kilobytes of data a year. But if you want to look at your phone traffic, I recommend not using these IoT things because it might be costly. But some of just regular ISPs offer this. So then you can use your own already kind of own subscriptions, and you can have like unlimited data for whatever you are paying for it in your country. And then you can push that to the private APN. So how to configure this? Like once you buy it, first you want to disable the traffic filtering if there is one, and then disable routing to the internet, because we don't want the devices to connect to the internet without us seeing it. Next, just site-to-site VPN between the private APN and kind of our cloud server. We could do a bunch of these things inside the private APN, but I kind of like to be in control of what I do and have like command line access to the server where the data is. But once we have the tunnel, we can set our cloud server as the default gateway for the network. And that basically means that all the data from the SIM cards first go to the private APN, and then it's just shoved through the VPN tunnel into our cloud server. And this basically should mean that the SIM card data is now on our cloud server. And so we need to add some mobile devices to the private APN. So we have our SIM card, we push it into the device. Some ISPs kind of require you to set some APN settings on the device, so they are not pushing anything to the devices, or they are roaming and you kind of need to set it up. And kind of some of the ISPs that say that you need to set the APN and you need to set it to this, you might be able to just set anything and it works, like on some carriers, and then some it doesn't, and it's weird. So yeah. And then there are some ISPs, like if you actually run both the kind of ISP and you run the kind of infrastructure and you run the cell towers and everything, then you have more control over things. So you have this easy checkbox that just redirect everything to the private APN, no matter what settings or anything there's on the device. So this is something that you want to look for when you're testing devices that don't want to be tested, because then you just, it thinks it's connected to normal internet, but it's connected to you. And this should be it. So profit. Let's see. So this is a proof of concept for this. So I talked about there's the IoT device connected to some ISP, and then there's a private APN configured inside the ISP. We have the IPsec VPN tunnel to our server, and then I'm SSH into the server. So yeah, let's see a demo. So here we have the trusty EPC. So it doesn't require fancy things. You just SSH into your server. My server is called private APN because it's connected to the private APN. Here we are running a TCP dump. So the interface is the IPsec VPN tunnel interface, and we're looking for traffic from host 10.222.01. And yeah, so we have the 222.01 SIM card. So that has like static IP that every time that SIM card is pushed to a device, it will get that IP address. And here it is booting up. And I'm really interested to see what it actually does. So let's see. Of course, takes some time to boot, but we have, yeah. And now we see some traffic. So it wants to know the time. So not that interesting after all. But if you leave the SIM card to the device, then you will see some unencrypted location data from that. So if you're running that tracker somewhere, the ISP knows where you're exactly where you're running it. It's one nice thing about this setup is also you just put the SIM card into something and then you see the traffic. So here is a modem. It's used to connect laptops or Ethernet-based devices to the internet with 4G. So here it's booting up. And like I said, it runs its own operating system. This is kind of a device, but it might also be a chip inside your phone or whatever. But they run their own operating systems. So once it's booted up, we can see that it has, so it actually says here 0 devices connected, but there's data there. So it's connecting to netgear.com and doing a lot of things. So it's downloading or checking for software updates, but luckily we can see that it's 443, so it's TLS traffic, and I couldn't use my CertMitem tool to hack that, so it can be okay, maybe. But now we at least know that it's not completely bad. And also, so here next up we have an iPhone. So we're booting it up, and I have the SIM card tray, and you can see me struggle getting it in. So this is the kind of hardest part of the setup, is actually putting the SIM card inside. One of our projects, the penetration tester, pushed the SIM card, and we heard this clunk, 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 because it was inside the device, and it was a competition, and we only had 30 minutes, so we had to shake it out of the device. But yeah, that was one joke, and that's all of them. So if we push the SIM card into the device, you can see it's actually locked. So this is the first boot before unlock. We push a SIM card into an iPhone. So let's see what happens. Yeah, so it's connecting to somewhere. So in here, I think it's doing some push notifications, so it's getting that. And I think it won't do that many things before you actually unlock it, but we're actually seeing something. So if you're into hacking locked devices, you might want to look into this. So yeah, so this is the demo. That's how easy to actually run it once you've set it up. Yeah, and let's get back to this question. So is there traffic over 5G as well? So of course, when I made this slide, I was like, hey, I will need to kind of check it. So this is my phone. I connected it to a Wi-Fi. Then I pushed the same SIM card into it, and this is what I see. So even though it's connected to Wi-Fi, you will see traffic. So these are the, I think, similar Apple push notifications. First, when I Googled these IP addresses, I went kind of, the first match was some weird Russian forum, and I got scared. But turned out it's maybe not some malware on my phone. But yeah, so there is something that the operating system does, so it overrides the Wi-Fi and pushes directly through the 5G. And if there is some kind of advanced malware, then it might also pop up here. So proof of concept, it's kind of yes. So from kind of moving on from the proof of concept to an actual project that you guys can use. So I collaborated with some IoT security experts. Some of them are here in the room, and they have had the same exact problems. So how do you, of course, they have the problem of how do you kind of look at your mobile traffic, and a bunch of them were in the phase of using their own kind of mobile base stations and software-defined radios, and kind of trying to use an IoT device that you need to kind of boot up, and then you need to press a button. But once it's inside the bag, it's kind of hard to press the button. And then I told about this, that hey, I kind of think this is the way to do it, and kind of I can see them contemplating kind of years worth of doing all the previous steps. And yeah, I also heard that they are running similar setup than I do. Like one person I know that has been running this, and a bunch of that haven't. So of course I'm from Finland. We have the kind of holy land of network connectivity. So of course everything works there. It's cheap and stuff like that. So I wanted to look at the US, where it's the opposite. It's not cheap. And also EU and global stuff. So it turns out a lot of ISPs and companies offer affordable private APNs, and they a little bit different, but I created this GitHub page, so it's online now, and you can see this to get some up-to-date things. So there are global ISPs there. So one of the $10 to set up and $20 per day thing works everywhere. If you've seen me before today, I've kind of given out a bunch of SIM cards, so you can try this out. But there should be something there that works in your country. But of course, the global IoT providers might be too expensive for your use case if you want to use more data. And if you want to use kind of your existing mobile plans, or you want to use your local ISP, you really should kind of show them this GitHub page and ask them, hey, do you want to go there on the GitHub page? So people will buy your services and figure out if you can make it work. If they have to do it manually, it will be expensive. So usually you want to look for something that has this self-service portal that works. But yeah. So this is my kind of full setup that I run. So I have the multiple IoT devices connecting to an ISP, and so a global ISP. One of the devices is in Helsinki, in my home. One is here in Las Vegas, and they are kind of in the opposite sides of the world, but they still connect to the same ISP, and they do the ISP stuff, go into the private APN. Different ISPs have different kind of tunnels, but they end up in my server. There I run WireGuard, but you can also set up another type of VPN for your pen testing, like workstations. So here I have on the right like a Kali Linux machine in Helsinki. Some of my colleagues maybe be in Stockholm and they have the same. And with this VPN server on the cloud server, so there's like one-to-one mapping. So IoT, like SIM card 1 goes to VPN profile 1, and the VPN profile 1 is opened in Helsinki, and then the traffic just magically goes there. So once you set up this, if you're working in a company, your colleagues will love you. You just hand them out SIM cards, you hand them out VPN profiles, and then like they're, hey, what's this? And you just, hey, push that in there, and then just double click that, and then you see the data, and everyone's amazed, and you're a hero. So it's that easy. But you can, of course, don't have to have this fancy setup. If you just want to do everything on the cloud server, you can do it there. Also, like I said, on the GitHub, you have a list of private APNs. The list is quite small because I use things that I found that work in Finland. When I flew here, I tested London. So in London, this works great. Here, I run into the problem that the modem I was using to kind of figure out if they work in different ways doesn't work in the US, because I noticed that the US has different mobile network stuff for some reason. But I tested that these work well on my phone here, so I just push it into my phone and I can see the traffic on the server. So confirmed to work well everywhere in the world. But yeah, so let's wrap up and go back to the kind of why would you want to do this. So curiosity and privacy. $50, couple days of tinkering on a device, like that's a good deal. It's actually the $15 is like one evening of like 6 hours of tinkering with this, so not much. And even if you use this, if you want to use it for a longer time, you might want to look into other options that are kind of less expensive in long term, but hacker spaces or even tiniest penetration testing companies, like $2K a year should be a no-brainer to if you really want to look at the traffic. Offensive security. So if you do penetration testing on IoT and you say to your customers that, hey, we kind of look at the device and look where it connects to, you really need some kind of setup to do this. And $2,000 a year versus an illegal setup that kind of you need to have your best engineers work a week on. So that's really expensive as well. These devices, especially in industrial IoT, they're everywhere, and people don't really look at their traffic that much. So there's just a handful of companies that actually I know that do this, but now anyone can do this. And like I said, maybe some new attack vectors for high security devices that if you can push a SIM card in and you get the data, then you can also send some malicious things to it. Defensive point of view. So these private APNs, like I connected to my server, but you can connect the IPsec tunnel to your existing firewall. So if you are running some kind of firewall, then you can just connect this to it. Kind of the first devices might kind of cost something, and then it costs more to add devices, but the cost goes down gradually. So if you have thousands of devices, it will be still quite inexpensive to do. And the mobile phone malware infections, they might not communicate at all over Wi-Fi or VPN. So there was this hack, some triangles or something, and they said that when they noticed the hack, they were scanning they were looking at their Wi-Fi traffic at their office, and they noticed that some of the phones were sending things to some C2 servers, and they also analyzed the malware, and the malware had these properties that it can detect if it's been run over Wi-Fi or VPN and not do it. So it might have been misconfigured to allow traffic over Wi-Fi, because why would you, people are looking at the Wi-Fi, why would you do your malicious stuff over that? So it might have just been a misconfigured malware that they happened to find through their Wi-Fi. So I might think that the advanced malware that sometimes are not that advanced might get better at this, or they might already be doing this and that was just one slip up. So yeah, if you're targeted by advanced malware, you might want to do this kind of thing. But you can find the project details, you can snap a photo of this to remember it, and you can find me here at DEF CON or the internet, and thank you for your coming here.